video. So what I'd like you to do is open up your handbooks to the area about covalent bonding. Okay, so this is just to remind you where we're at. We are in cycle 3 bonding, intramolecular bonding. We've already done ionic bonding, and when we left off last time, we were right just at the very beginning of covalent bonding. Okay, so I'm going to have you go all the way down here to definitions of covalent bonds. We're going to skip these labs. I'm going to do some labs, but for right now, we're going to start right here. So whenever I'm lecturing to you in a video format, there's going to be moments when I'm going to have you write things down. So just pause me if you need to. There's also going to be things I'm going to write and things I'm going to say. If you think something I say is interesting, go ahead and pause me and write that down as well. Whenever we're solving problems, I'm going to go through and solve all of these problems with you. And I say with you because what I'm going to do is do some examples. And then what I'm going to do is say, okay, stop, press pause, solve this on your own. Okay. I'm not going to pause on my end. You pause on your end. When you're ready to see the solution, just go ahead and press play, watch me do it. And doing that over and over again is a nice way for you to control your own learning. So we talked about ionic bonds. Now remember, covalent bonds are really bonds between two elements. So let's say we had element A and element B, and these elements both want to be like noble gases. So they both want to gain electrons. So you can't have that transfer and they end up sharing, right? And we get that covalent bond that we just draw as that nice line, but it's really important to remember that this line really contains two electrons, right? This is a real bond. It's going to create real structure, which is going to be essential when we talk about proteins, specifically the protein on the surface of the coronavirus binding the receptor on the surface of endothelial tissue. That happens because of molecular shape, which happens because of covalent bonding. Well, how do we figure out the number of covalent bonds? There's a really simple formula. I know we went over this. We take the number of valence electrons anybody wants, okay, and we subtract that from the number of valence electrons the whole molecule has, okay, and that's going to give us this discrepancy between what it wants and what it has. Okay, and with noble gases, for example, we don't have that discrepancy. But remember, all of those electrons are locked here in covalent bonds. So we're just going to go ahead and divide that by 2, and that's going to give us the number of covalent bonds. So recall that all elements want 8 valence electrons. It's that S2p6 valence structure that it's looking for. Okay. But we know hydrogen only wants 2 and boron wants 6. So these are some exceptions to really watch out for. Also, remember in terms of valence electrons, just do the electron configuration and count the outer s and p electrons. Oxygen, S2p4, so that's 6, etc. So let's go ahead and do some examples of this. So let me erase this little friend right here. All right. So for NH3, well, how many valence electrons does this whole thing want? Well, we know that nitrogen wants 8 and each hydrogen wants 6. 8 plus 6 is 14. How many does this entire molecule have? Well, nitrogen ends in S2p3 and hydrogen S1. So nitrogen has 5 and hydrogen has 1, which gives it a total of 3. Well, that's 8. 14 minus 8 is 6, divided by 2 is 3. So we're going to put nitrogen right there in the middle to make it symmetrical. We're going to put these hydrogens around the outside. And we're going to see, does it have what it wants? Well, the hydrogen wants 2, good. 2, 2, good. But nitrogen here only has 6, remember, because each of these counts as 2. So it needs 1 lone pair electron. I'm going to do the lone pair electrons in a different color because they end up being really, really, really important when we talk about molecular shape. Okay, so for oxygen here, how many does oxygen want? Well, there's 2 of them. Each one wants 8, so that's going to be 16. What about have? Well, there's 2 of them. Each one has S2p4, so that's going to be 12. So 16 minus 12 is 4, divided by 2 equals 2 bonds. So right next to each other, there they are. And does each oxygen have what it wants? No way. It needs 2 lone pairs. 2, 4, 6, 8. 2, 4, 6, 8. Okay, so we're good there. Let's now go to this BH3. Remember, we're going to have an exception here. B only wants 6. So that B wants 6, and that hydrogen actually wants 2. So that's a total of 12, because 3 times 2 is 12. Well, what about have? Again, this is a really good one because it encapsulates both exceptions. Hydrogen only wants 1, so that is going to be 8. So I'm sorry, 6, 6, 3 plus 3 is 6. Come on, Ramsey. 6 divided by 2 equals 3. So B, H, 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 covalent bond, covalent bond, covalent bond. So everyone's satisfied. They have to share because they don't have enough to have their 8, or in this case 6 or 2 electrons. And again, hydrogen has what it wants, and actually boron does as well. Really common for people to put that lone pair there, but it doesn't need it. Okay, so now we're going to look at 2 polyatomic ions, phosphate and this other thing over here. We don't need to worry about the name of that. So PO4 minus 3. So what does that -3 mean? Well, that -3 means that it has 3 extra valence electrons that it got in order for it to have that -3 charge. Recall, electrons are negative. If electrons are negative, and -3 means 3 more. You're simply just going to add that to the have. If it were +3, you'd have 3 less. Have 3 less, you'd take away from that. Okay, so here we go in this case. What do we want? Well, this is 8. This is 32 total, so it wants 40. Have. This has 5. P is S2P3, and each of these is 6. So that's 24 plus 5 is 29 plus 3 extra. So you're going to do 29 plus 3. Remember, we add it there. Okay, so that's going to be a total of 32. 40 minus 32 is 8, divided by 2 equals 4. So no difference there. P, 1, 2, 3, 4, O, 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 O. Okay, now, does everybody have what they want? Well, P, 2, 4, 6, 8, good to go. Each of these oxygens actually needs 3 lone pairs, because each of these oxygens only has 2. So I know it's kind of annoying, but we got nothing but time right now. Okay, so whenever you do a polyatomic ion, that means a group of atoms that all have a charge. We put the whole thing in brackets like this. Okay, and we say -3. Okay, so there's the answer to that one. Now let's look at this one. Well, that's got a positive charge. So what does it want? 8 plus 8, that's going to be 16. Have. What do we have here? We have 5 plus 9. 5 plus 4 is 9, minus 1. So 9 minus 1, okay, equals 8. Okay, so 16 minus 8 is 8, divided by 2 is 4. P, H, 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 P, 2, 4, 6, 8. Sweet. Each H, 2, 2, 2, 2. Good to go. Okay, so we are fine there. All right, so there is a bunch of examples. So now what we're going to do through here is go through these, and I'm going to say for each of these, you do it, press pause, okay? And then when you're done, press play. But for all of these, I want you to leave this molecular geometry section blank. That's going to be the focus of our next class, and that is going to be heck important when we talk about function. And in this case, we're talking about viral function. So again, leave this whole section blank, please. Okay, so I want you to press pause and try CS2. Okay, so for CS2, I outlined it this way, valence electrons that it wants. Okay, so 8 here, 3 times is 24. Valence electrons that it has. Here we have 4 S2P2, and then we have 12. 12 plus 4 is 16. 24 minus 16 is 8. Divided by 2 is 4. So Lewis structure. Let's look for symmetry. Put the C in the middle. S, S. 4 bonds. 2, 3, 4. And I always do it that way to make sure that I'm doing it correctly. So 1 for you, 1 for you, 1 for you, 1 for you. Now, does everybody have what they want? Okay, carbon has 2, 4, 6, 8. We're good there. Does sulfur have what it has what it wants? 2, 4, 6, 8. Now it's good. 2, 4, 6, 8. Now we don't need brackets there. Again, leave this blank, please. Okay, please press pause and do pH 3. Okay, so now we're looking at pH 3. So what does it want? P wants 8, and each of these, this total wants 6. So this is 14. 14 minus P is 5, plus 1, 2, 3 is 8. 14 minus 8 is 6, divided by 2 is 3. Put the P in the middle. H, 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 boom, boom, boom. Now, does everybody have what they want? Well, H's have what they want, but P doesn't. 2, 4, 6, it needs 2 more. Okay. Go ahead and try OBR2. Please press pause. Okay, so let's go through OBR2 together. So all of these want 8. That's going to be 24. O wants 6, and each of those wants 7 because it ends in S2P5. So that's going to be 6 plus 14. That's going to be 20. Okay, so we have a discrepancy of 4. Locking those things in covalent bonds. Remember, that's why we're dividing by 2. And that's going to give us 2 bonds. We want symmetry. So we're going to put O in the middle and Br on the outside. 1, 2. Now, does O have what it wants? 2, 4. Nope. 6, 8. Does Br have what it wants? Nope. 2, 4, 6, 8. 6, 8. Great. Leave it. SO2. Here we go. So SO2 is a really common one for people to mess up on. SO2. So total here we have 24. Oh, sorry. Press pause and start. Okay, listen now. So we have 24, and then each of these has 6. So that's going to be an 18 divided by 2. So we're going to have 3 here. So S in the middle for symmetry. O, O. 1 for you, 1 for you, 1 for you. Now, if you started on this side, you might end up with that double bond on the other side. And it turns out it actually fluctuates back and forth. And that's a concept we'll talk a lot about in biochemistry that adds stability to molecules. And that's called resonance. Really, this double bond can resonate back and forth. Sometimes you're going to see that actually drawn where they'll draw a dotted line like that. Okay, but you don't have to worry about that right now. Does S have what it wants? No way. 2, 4, 6, it needs that. Does this one have what it wants? No way. 2, 4, 6, 8, 2, 4, 6, 8. Okay, leave that blank. CF4. All right, so here we go. CF4. What am I gonna do? Oh, add them all up. So we have 5 molecules. 5 times 8 is 40, minus 4 plus 28. So that's gonna be 32 divided by 2 is 4. And CF, notice how just you do enough of these, it becomes really easy. And I forgot to tell you to press pause. I'm sorry. Hopefully you figured that out. Okay. Now, boop, 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 boop. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Leave the molecular geometry blank. Okay, so now we got a polyatomic ion. This one's a really important one, nitrate. Nitrate you probably have heard of. It's super, super, super prevalent in food additives. Definitely affects blood pressure big time. Again, we'll talk more about that when we talk about treatments for blood pressure. Let's talk about NO3 minus though right now. So what does it want? Okay, it wants 4 times 8, so that's 32. And what does it have? Remember, we're going to be adding one more to have. So have here is going to be 5 plus 18, because 6 times 3. So 5 plus 18 is 23. And then we're going to add one more. So that's going to be 24. We're adding one more because of that. And we're going to divide that by 2. So 32 minus 24 is 8, divided by 2 is 4 bonds. So NOOO. Now, just like SO2, wherever you start is going to affect where that last double bond ends. 2, 3, 4. So again, this could be anywhere around there. So 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8, and this one 2, 4, 6, 8. Now, am I done? No, because it's a polyatomic ion. So, like we saw in our notes, we need to put a negative sign around it. I saw that up here. Okay, so let's try a couple harder ones now. Let's try CH2O. Okay, so press pause and try this on your own. Okay, so here we go. What does it want? Well, it's got 8 here. Okay, so it's 8 plus 4 here plus 8. So this is going to be 20 total that it wants. What does it have? Well, it has 4 here plus 2 is 6 plus that is 12. So, did I get that right? 6, yes. Divided by 2, okay, that's going to be 8 bonds. Why am I writing that there? Okay, so who's going to go in the middle here? Well, in a situation like this, you've got 3 elements. We know that we're going to put everybody around 1 for symmetry. Usually the element that shows up first goes in the middle, and usually that element's carbon. We know that carbon has these 4 lone pairs, and it's got a lot of bonding power. Carbon can make 4 covalent bonds. So always put carbon in the middle if you can. So we're going to put carbon in the middle, O, H, and H. So now we got this weird situation where we're going to go 1, 2, 3. Well, we got to decide where it's going to go. So press pause and you put where it's going to go. Okay, so hopefully you chose O, because if I put it here for H, it would have violated what H wants, and we don't want that to happen. So 2, 4, 2, 2, H's are good. 2, 4, 6, 8, carbon is good, and this oxygen is not good. 2, 4, 6, 8. Okay, so let's go ahead and do HCN. Here we go. So for HCN, what do they want? Well, H wants 2, this wants 8, and that wants 8. So total is 18. What does it have? Well, this has 1, this has 4, and this has 5. So that's going to be 10 divided by 2. So we have 4 bonds. H, C, N. Put carbon in the middle. So 1, 2. Okay, we have 2 more bonds. You press pause and you put where they're going to go. Okay, hopefully the bonds you chose are going to go next to the N because hydrogen can only have 2. So let's go ahead and put in lone pair electrons. So 2, 4, 6, 8 around that carbon. And there we go. So good there. Ooh, another polyatomic ion. Here we go. CO3, 2 minus. So what does it want? Remember, those extra 2 are not going to go for what it wants. What does it want? Well, we have 4 elements times 8, 32. No exceptions there. Minus, what does it have? Okay, so it has 4 here plus these 18. So that's 22, 23, 24. So 22 plus 2, those 2 were added there. So that's 32 minus 24 is 8 divided by 2. So that's going to be 4. So carbon in the middle, O, O, O. 1, 2, 3, 4. This time I ended up with a double bond up there. Remember, that's okay. So is carbon good? 2, 4, 6, 8. Yep. Is this oxygen good? Nope. 2, 4, 6, 2, 4, 6, 2, 4, 6. I'm sorry, that should have been 8. Okay, so am I done? No, I'm not. I got to put these in parentheses. Okay. N2. So we're going to finish this one off right here, and then I'm going to have you do the rest on your own. So N2. Here we go. So what does it have? I mean, what does it want? It wants 16. 8 times 2, what does it have? 5 times 2 is 10. Divided by 2 is 3. So n, 1, 2, 3, and boop, 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 boop. Good to go there. All right, CH3OH. This one is pretty tricky. I want you to press pause and try this on your own. Okay, so what does it want? Well, we have a carbon and an oxygen together. Those are going to want 16 plus these 6 here. So that's 22. Plus another hydrogen. So that's 24. And what does it have? Well, it has 4 plus 3 is 7 plus this number 6 is 13, 14. So 14 divided by 2 is 5 bonds. So we have carbon, hydrogen, 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 oxygen, hydrogen. So it's got 5 bonds. So 1, 2, 3. If I do a 4 there, I'm stuck because then I lost my bonding power on my carbon. So what I'm going to do is do 1 there and then 1 here. Okay. So lone pairs 2, 4, 6. 2, 2, 2, 2, that's fine. 2, 4, 6, 8, that's good. 2, 4, 6, 8. Okay, we're going to do NH4 plus, and then we're going to be done with this page, and then I'm going to tell you what you're going to do next, okay? So NH4 plus here, remember that plus is going to be 1 left from the have. So we have 8 plus 8 here, that's going to be 16 minus have. So have here we have 5 plus 4, that's 9, minus 1 is 8. So 16 minus 8 divided by 2 is 4. N, H, 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 H. Okay. Does everybody have what they want? So N2468, N's good. H2222, that's good. Okay, and we're going to put it in parentheses and put that plus at the top. So what I'm going to have you guys do now is go through and do the rest of these practice problems on your own. And that's going to be what I'm going to have you turn in the checkout phase. So hopefully that was clear. You have this video. You can review it anytime you like. Thanks a lot. Bye.